Hi everybody, I want to introduce you to a new type of factoring or new type of expression that is called quadratic form. So quadratic form is a pretty neat type of factoring. It's when things behave like a quadratic, despite the fact that they may not be a quadratic. They may be some type of higher order polynomial. I'm actually going to skip over this slide that has explanation on it, and if you'd like, you can pause and look at it. I'm going to come back to it so you can look at it later, and hopefully you'll have a better grasp there. So what I want to start with is I want to take the answer to one of these problems, and I want to FOIL out these binomials and see what happens. So I have two binomials in an equation, y equals x squared plus 4 times x squared minus 2. When I FOIL those out, I get y equals x to the fourth minus 2x squared plus 4x squared minus 8. And when I combine like terms, I get x squared plus 2x squared, x to the fourth plus 2x squared minus 8. What I want you to notice about this is that this factors very similarly to y equals x squared plus 2x minus 8. That would factor to y equals x minus 4, x plus 4 rather, times x minus 2. So we're back to following the same pattern of what multiplies to negative 8 and adds to 2x squared. And it also involves an x to the fourth. Okay, so let's take a look at doing one of these problems forwards instead of in reverse. I have y equals x to the sixth plus 4x cubed plus 4. And the quadratic that I want to think of is y equals x squared plus 4x plus 4. See how the coefficients are the same there? It's just the powers that are different, the exponents are different. So we think about how that would factor. That would factor to y equals x plus 2 times x plus 2. Now, if I want to make things that add instead to x cubed and multiply to x to the sixth, I'm going to have to use x cubed plus 2 times x cubed plus 2. So you can FOIL this out to check. The firsts give you x to the sixth. The outers and the inners both give you 2x cubed. And the lasts give you 4. So when you combine your like terms, you get the equation that we started with. Now the tricky part is usually figuring out, well, what goes right here? How do I know what to put there? Here I'm using cubes. On the slide before, I was using squares. So what is it that I put there? And I'm going to actually figure that out by looking at an original quadratic. When I had x's as my middle terms, I have x's in the parentheses. Here where I have x cubes as my middle term, I have x cubes in the parentheses. Okay, so let's take a look at a tough one. I have x to the fourth y squared plus 7x squared y plus 10. Now, I don't blame you if you look at this and you think, wow, that's really, really hard. Think of it instead like this. I'm already using x's and y's, so I'm just going to use u for a second. If I had u squared plus 7u plus 10, that would factor to u plus 5 times u plus 2. So the difference here is that instead of having u, I have something way more complicated. I have x squared y plus 5 times x squared y plus 2. Again, we're looking at that middle term of x squared y, and that's what's going in the parentheses here. If you want to, you can FOIL that back out. Let's just take the firsts, for example, and make sure that we believe that that multiplies to what we want it to. X squared y times x squared y. This is one of the reasons we've been doing all these exponent problems. That is x to the fourth y squared, which is exactly what we were hoping for. So this is an example of quadratic form. That's when things factor like quadratics, but aren't necessarily. So here's that long-winded explanation from before. This part right here is basically saying instead of using x, we're using something more complicated. So use an expression that is more complicated. So the example here is saying instead of using x, use x squared. So you would get y equals ax to the fourth plus bx squared plus c. This still follows the same pattern, but instead of being a quadratic, it is a degree 4 polynomial. All right, so here's a challenge problem. I want you to pause the video and see how far you can get from this. It is all sorts of fun. All right, I did the first step for you. See if that makes sense to you. This is a difference of squares. We don't normally think of x to the sixth as a perfect square, but x to the sixth is x cubed squared. And 64 is obviously 8 squared. All right, pause the video now and see if you can get any further. All right, so like I said, this one was crazy. X cubed minus 8 is a difference of cubes. It follows that special pattern. And x cubed plus 8 is a sum of cubes. It follows a special pattern. As an added bonus, this is also, the original was also a difference of cubes. All sorts of fun stuff going on. If you've got questions about that, you can feel free to ask me. All right, see you later.